Everybody has imbalances in how muscles can grow, how well muscles can grow, or how poorly or how challenging it is for their muscles to grow. Now you know how to devote a small portion of your exercise, 10%, in order for muscle and lactate to benefit other tissues, namely your heart, your liver, and your brain. I'd now like to shift our attention to how to use specific aspects of muscular contraction to improve muscle hypertrophy, muscle growth, as well as improving muscle strength. There are a lot of reasons to want to get stronger, and I should just mention that it's not always the case that getting stronger involves muscles getting bigger. There are ways for muscles to get stronger without getting bigger. However, increasing the size of a muscle almost inevitably increases the strength of that muscle, at least to some degree. Reasons why most everyone should want to get their muscles stronger is that muscles are generally getting progressively weaker across the lifespan. So there are a lot of reasons to use resistance exercise that extend far beyond just the desire to increase muscle size. So there's an important principle of muscle physiology called the Henneman size principle. And the Henneman size principle essentially says that we recruit what are called motor units. Motor units are just the connections between nerve and muscle in a pattern that staircases from low threshold to high threshold. What this means is when you pick up something that is light, you're going to use the minimum amount of nerve to muscle energy in order to move that thing. Likewise, when you pick up an object that's heavy, you're going to use the minimum amount of nerve to muscle connectivity and energy in order to move that object. So it's basically a conservation of energy principle. Now, if you continue to exert effort of movement, what will happen is you will tend to recruit more and more motor units with time. And that process of recruiting more neurons, as you recruit more and more of these motor units, these connections between these lower motor neurons and muscle, that's when you start to get changes in the muscle. That's when you open the gate for the potential for the muscles to get stronger and to get larger. The Henneman size principle is kind of a foundational principle within muscle physiology. You can greatly increase muscle hypertrophy, muscle size, and or muscle strength if that's what you want to do. And you don't necessarily have to use heavy weights in order to do that. First of all, let's just talk about what hypertrophy is and what strength changes in the muscle are. What is changing when muscles get larger or stronger? And there are really just three ways that muscles can be stimulated to change. So let's review those three ways and talk about what happens inside the muscle. So there are three major stimuli for changing the way that muscle works and making muscles stronger, larger, or better in some way. And those are stress, tension, and damage. Those three things don't necessarily all have to be present, but stress of some kind has to exist. Something has to be different in the way that the nerve communicates with the muscle and the way that the muscle contracts or performs that makes the muscle need to change. But basically, along the length of the muscle, you have what's called myosin. And just think of myosin as it's kind of like a wire. It's like a bunch of beads and wires that extend across the muscle. Myosin is surrounded by these little beads called actin. The way muscles get bigger is that basically the myosin gets thicker. It's a protein, right? And it gets thicker. So the myosin head is the balloon. When you stress a muscle properly, or you give it sufficient tension, or you damage the muscle just enough, there's an adaptive response that takes place where protein is synthesized, and it's a very specific protein. It's myosin. The myosin gets thicker. In other words, the balloons get bigger. So the way to think about muscle growth and the way to think about muscles getting stronger is that those balloons get bigger and the muscle gets thicker. The neuron has to tell the muscle to get stronger. And it does that through what we call a signaling cascade. It talks to the muscle in terms of chemicals. It doesn't whisper to it or shout at it, hey, get bigger. What it does, it releases certain chemicals that within the muscle, there are certain chemicals released that make those balloons, as I'm referring to them, the myosin, get thicker.